It's Dakota Prep question walkthrough, except in this video, we don't have specific questions. We are going to do a walkthrough though. In this video, we're specifically going to be talking about ladder diagrams. The Red Seal exam does have a number of these on there. So I figured it was just a good idea to go through these and just give you a general overview of the things you can expect to see and the types of questions you can expect to get. So right off the bat, let's just go through our components. Most of these, hopefully you know, this is a normally closed button, normally open button. Over here, we have our outputs or the things that we want to happen. So this is our motor 1 relay, time delay relay, motor 2 relay, motor 3 relay, motor 4 relay, and then down here, I've got a lovely little light. The A stands for amber. Now, we've got a couple of other things here as well. This right here, now what's funny about this is it actually has 4 different names. So you may have heard it referred to as a maintaining contact, maintaining, a holding contact, but my friends, it's also known as a sealing, that's supposed to be an N, sealing contact or an auxiliary contact. The only thing these have in common is they mean the same thing. So essentially, all of these refer to any type of contact that is in parallel around something else. So we have maintaining, holding, sealing, and auxiliary. Is that confusing? Absolutely. Don't blame me. I didn't come up with it. Okay. One of the things you absolutely have to make sure that you are good with are the symbols. If you do not know what these symbols or types of switches are, you are absolutely going to run into problems. So right here, this, whoops, let go here, blah, blah, blah. This little guy is temperature. Temperature. Now, depending on the context of the ladder diagram, if it's electrical, it's going to refer to a thermostat. If it is instrumentation, it's going to be a thyristor. And if it's electronic, it's going to be a thermistor. The only thing these 3 things have in common is the fact that they're temperature. So pay attention to the context of what the question is. All right, let's get rid of this. Wachoo, so fast. All right, we have this guy right here, pressure. We have this guy right here, which is flow. And the 2 that we're missing in this one specifically is float, which looks like this. And I prefer to think of this as a balloon. We all float down here, Georgie. It's a little red balloon. So it's a float switch. And then we're also missing this guy. Now, we have to be very careful because this guy right here is a triangle and that's flow. This guy here has a triangle, but he's limit. And the difference between the 2 is this guy looks like a knife. And the way I like to think of it is I have reached my limit with your shenanigans, so I am going to stab you with my knife. So limit looks like a knife. Flow looks like that little triangle there. Haha, did you notice everything disappeared? The magic of technology. Anyway, we've got our last guy right here. Now, this one here, we've got 2 options. Sometimes you'll see it like this. Sometimes you'll see it like this. Those are the same thing, little arrows on them. And then our other one is this guy. Actually, you know what? I'm going to draw it down a little further here. All right, this guy right here. These ones both belong to timing delay relay, which we find right here. So with timing delay relays, you can have normally open contacts, you can have normally closed contacts, but the big difference is we can also have this type of switch and this type of switch. One of them is on delay, one of them is off delay. And because I love having handy things to help me remember, I remember on delay, we got a guy in a cowboy hat and he's sitting on a horse and he's going on delay, woohoo! Give him a little smile there. So on delay, looks like a guy sitting on a horse. So what is the difference between on delay and off delay? That's a good question. Thanks for asking. Well, when it comes to timing delay relays, the timing delay relay starts timing when the relay turns on. That's this guy. Off delay, this one, the timing delay relay starts timing when the circuit turns off. There's a very big distinction between these two. So how does it apply in this situation? Well, when we're looking at this right here, when this turns on, oh, that one's off. When this turns off, this will close. If this one, if this one here looked like, look like the cowboy, when this turns on or is energized, then this will close. It's mostly, well, I shouldn't say it's mostly, it is used very often for safety purposes. So a good example would be, I turn the motor on. 5 seconds later, a red light goes on to say, hey, don't approach, this motor is on. I turn the motor off, and 5 seconds later, a green light turns on to say it's safe to approach. If you guys remember taking from PLCs, you also had timers when you were doing PLCs. It's the same thing. In this specific example here, I'm going to be using get back here, switching this out in different ways. So just pay attention to whether or not I've drawn over top of it. All right. Now, when we get a question in the C of Q and we want to figure out how do we go about this, the worst possible thing you can do is start at the beginning. That's a big no. It does not matter how good you are at these. You have to remember, each question's only worth 2 minutes. And it's going to take you 2 minutes just to figure all this stuff out, when that's not the point. You don't need to figure everything out. You just need to figure out what the question is asking for. So let's just come up with an example. What needs to happen in order for get over here again. Boy, I never remember to do this. In order for M3 to be energized. So what needs to happen? Right off the bat, I'm going to head over to M3. I'm immediately going to work backwards. In order for M3 to be energized, M2 needs to be closed. So this one right here needs to be closed. So M2 needs to be on. My flow switch needs to be closed. My pressure switch needs to be closed. And my temperature needs to be closed. Awesome. Well, this guy, we're now going to head over to M2. Because in order for this to close, M2 has to be energized. Now, how does M2 have to be energized? This guy right here has to close. Our off delay. Now, again, as we're looking at this, this needs to close. This is attached to this guy right here. Now, let's pretend we actually doesn't matter at this point what this is. We need to see that this guy needs to be either on or off. So now we go up, and in order for this to either go on or off, we have to do our very basic stop-start. This is our start with our maintaining, auxiliary, sealing, or holding contact, and our normally closed start button. So we always start at where we're going. We work backwards. And actually, it's kind of funny. By the time you're done, you end up with a bunch of Zs or Zs, depending on how you want to pronounce it. So let's do this very specifically with an off timer, which is what this one is. Because remember, this guy with the arrow going down is an off delay. So this is going to close when this turns off. So in order for M3 to be energized, M2 needs to go on. Boom. And of course, these three things need to close. But for right now, we're going to pay attention to this. M2 needs to close. Boom. If this is off delay, this is only going to close when this turns off. So this is actually a fairly simple question, because the only way for this to turn off is for our stop button. Boom. All right, so let's move on, make it a little bit harder. Let's change this guy. I think I've only got like 2 colors here. Oh, that's a terrible color. Let's get rid of that. Let's keep using red. Let's change this guy to an on delay. So now it's going to close when this one turns on, when this is energized. We'll still stick with M3. M3. So in order for M3 to be energized, M2 needs to be energized. Go to M2. In order for M2 to be energized, oh, we hit this bad boy. In order for this guy to close, we got to go here. In order for this guy to close, we got to go here. Boom. Super easy. As long as you work backwards, because again, none of this stuff down here matters. Technically, this doesn't really matter either. The only thing that matters is M3 to M2, M2 to on delay to TDR, TDR to start button. Boom, done. All right, let's get rid of this stuff here. All right. Now let's look at down here. When will this amber light, A stands for amber, amber. When will this amber light go off? All right. So right now, because everything's powering through, this amber light's going to be on at all times. But when is it going to go off? So again, we started the amber light. In order for it to go off, M2, this right here, needs to be open. So in order for that to happen, we head over to M2, it's already open. So for the amber light to go off, M2 also needs to be off. Otherwise, my amber light's going to be on all the time. Now, let's try M4. What has to happen in order for M4 to go on, go off, whatever? We're going to work backwards. Well, look at this. As we're looking, oh, look, M4 is on all the time. On all the time. That's weird, but you know what? Just go with it. All right, so what do we do in order to get M4 to turn off? Again, we're going to work backwards. Start at M4. In order for M4 to go off, M1 needs to be off. M1 needs to be off. And the amber light needs to be off. Amber light needs to be off. How do we get the amber light off? Amber, we work backwards. That means M2 needs to be on. Does this make any sense? No, because I switched this out. But that's how we do that. We always, always, always work backwards. And because the C of Q is now done on a computer, it's a little trickier because you can't really follow with your finger. But you are given a piece of scrap paper. And I highly suggest, just me personally, that when you're going through the steps of working backwards, you keep track, kind of like what I did. I wrote M4, and then underneath I wrote M1, and then amber light as I'm going backwards, or as I'm going this way, this way, this way, this way, this way. All right. I hope this helps. Oh, that was terrible handwriting. That's supposed to be an H. There you go. Ladder diagrams. Ta-da!